Quiz 8 for Math 112. These first two problems we're using the law of cosines. Law of cosines, there's a couple different versions. Actually, there's 3 different versions of it. But I think the version that you'll want for each of these problems is that c squared, little c, equals a squared plus b squared, looking a lot like Pythagorean theorem at this point, except you have to subtract off this 2ab cosine of angle c. So this is the formula that I'll use, and basically I'm just going to plug in values and solve for what I don't know. So I need to know little c. I know that little a is root 2. So the square root of 2 squared is just 2. Plus b is 5, so b squared would be 25. Minus 2 times the square root of 2 times 5, which is 10 root 2. Cosine of capital C being 45 degrees. So I got c squared is 27 minus 10 root 2 times root 2 over 2. So I got that c squared is equal to 27 minus, well, it's minus 10. I guess the reason that works, can I just write that? I guess I can just write that. Root 2 times root 2 is just 2. And that 2 divided by this 2 is just 1. And 10 times 1 is just 10. So c squared is equal to 17. So c is equal to the square root of 17. Technically plus or minus the square root of 17 if you're just thinking about solving this equation, but since we're talking about a side length, it's got to be the positive solution, c equals root 17. Same idea here, start out with the same formula, c squared equals a squared plus b squared minus 2ab cosine c. And plug in, except now what you're plugging in is little c is root 13. So root 13 squared is 13. A is 2 now, so 2 squared is 4. B is 3 root 3. That's a little bit of a pain to square. Maybe I'll leave it as 3 root 3 squared and talk through my steps in the next line. Minus 2, I'll write it out, 2 times A times B times cosine of C. So let's see if I can clean some stuff up. 3 root 3 squared is 3 squared times root 3 squared. But 3 squared is 9, and root 3 squared is 3, and 9 times 3 is 27. And then here, 2 times 2 is 4, and 4 times 3 is 12. So I get 12 root 3 cosine of C. And so now, I don't know, maybe I'll add the 12 root 3 over here. 12 root 3 cosine C, that is. And then over here I got 31. But when I take away 13, I'll have 18 left over. So I got that the cosine of C is equal to 18 divided by 12 root 3. Where to? Maybe up over here. So 18 over 12 root 3, I can cancel out a 6 from the numerator and the denominator and make that 3, the cosine of C equals 3 over 2 root 3. And in fact, you can do even better than that, because if you rationalize this thing, you get that it's 3 root 3 divided by 6. Multiplying the top and the bottom by root 3, that makes this a 3, and 2 times 3 is 6. You got 3 root 3 on the top. If I can simplify again, I can say this 3 and this 6 cancel out and leave me with a 2 on the bottom. So I get the cosine of C equals root 3 over 2. And if the cosine of C equals root 3 over 2, I can think in terms of my unit circle. I don't know, do I need to draw a picture somewhere? There's my unit circle. And I'm looking for the point where the x-coordinate is root 3 over 2. That's here or here. But I couldn't possibly be talking about this angle because this angle is damn near 360. I'm talking about a triangle, so the sum of the angles have to be 180. So that doesn't make sense. It's got to be this angle right here, 30 degrees. Or, if you prefer radians, it would be pi over 6. Either of those are totally fine with me. If you said the arc cosine of root 3 over 2, you'd be correct. It just wouldn't be all the way simplified. So my guess is you'd lose like a point or something, but you got the right idea. All right, I think that's all I got for law of cosines. And there's a couple problems where you're simplifying trig expressions. And the trick here is to turn everything into sines and well, a couple different ways you can do these. At some point, you want to change everything into sine and cosine. My guess is that you would do that first, since I've been telling you to do that. But just note that you do have two terms here. You could factor out a cosecant of x from both of them if you wanted to. But I'm guessing, well, I'm going to do it that way. Factor out a cosecant of x, and then I have 1 minus cosine squared left over, right? If you pull out these two cosecant of x's and put it right here, you got 1 minus cosine squared. But cosecant of x is 1 over sine of x. And 1 minus cosine squared of x is sine squared x. So really what I have is sine squared x over sine of x. I can cancel the sine from the top and the bottom to get that this entire thing simplifies down to just sine of x. Lots of other ways you could have gotten there too, FYI, but completely simplified, it should look like this. All right, next one, same basic idea. You're given this mess. I think I'm just going to kind of fight with this one. I'm going to convert everything into sines and cosines. So this cosecant here I could say is 1 over sine of x, and then cosine of x minus cotangent of x. Let's see, 2 cotangent of x. Cotangent is cosine of x over sine of x. And then from that entire thing, I want to subtract tangent of x. Ugly looking, but there's hope. 1 over sine times cosine, that's just cosine of x over sine of x. Or cotangent of x if you prefer. And from that, I want to subtract 2 cosine of x over sine of x. And I guess I should make this sine over cosine at this point. I don't know if you have to do that now, but at some point you want to make tangent sine over cosine. Let's jump up here so I have plenty of room. Note that in the denominator here, I have a common denominator of sine of x. So if I leave this top alone, down on the bottom I can mash these two fractions, or rational expressions technically, together. 1 cosine of x minus 2 cosines of x is negative 1 cosine of x. And that's divided by the common denominator of sine of x. And then remember, you still have to subtract sine of x over cosine of x. So if you think about this as negative 2 divided by 1, in fact I almost wish I had written it like that, negative 2 over 1, you can take the reciprocal of this to divide these two fractions and get negative 2 sine of x divided by negative cosine of x minus sine of x over cosine of x. But wait a minute, don't these negatives cancel out? Yup. So you get 2 sine of x over cosine of x minus 1 sine of x over cosine of x. So if you have 2 of these things and you get rid of one of them, you got one of them left. And you can just write your denominator one time. You get sine of x over cosine of x, which I think I'd be fine with this answer, but it did say your answer should be a single trig function, so I guess I should change this into tangent of x if I really want to follow directions. That would be the answer. I guess that ends this problem, and so that ends this quiz.